Hey everyone, Johnny here. About 4.5 years ago, I did a video about Blender 2.93, and in that video, I showed how to do a material shift using geometry nodes. Now the thing is, the method I used to do that was before fields became an option, and the nodes that I was using were actually removed from Blender. Since then, I've gotten a few questions about how to do that same effect in the current version of Blender, which is 4.5.1. This is how I would accomplish the same thing using a modern version of Blender. For a little setup, I've got a Suzanne head here with a geometry nodes tree already added to it. And then after that, I'm using a subdivision modifier, and I've got this on adaptive subdivision, which you can enable if you go under your render settings and you choose the experimental feature set. In addition, I have a PBR texture that I've put on the Suzanne head that I imported from Polyhaven. Additionally, I have this other principled BSDF node that has a chrome material on it. So if I disconnect the existing shader and then connect this one, you'll see that I have just this metallic chrome shader. And we want to blend seamlessly between these two. To control the blending, we're going to use a secondary object, and for that you could use really anything, but in this case I'm going to use an icosphere. So I'll add an icosphere, and now I'll go over to my node tree connected to my Suzanne head. We'll want to bring the icosphere into the node tree, and we'll do that using an object info node. This will let us connect an object that's outside of our node tree into our node tree. We could do an eyedropper select of the icosphere from right here. Instead, I'm going to connect up a socket so that I can choose this for each object that I wanted to apply this modifier to. So over here in my modifier panel, I could do my eyedropper and then get the icosphere. Now, because we want the icosphere's position relative to the object we're working on, we want to set this to relative position. Our goal here is to set a named attribute on the Suzanne head that we can then use in our shader to determine the mix between one texture and the other. So to set a named attribute, we use the store named attribute node. The geometry we want to add the named attribute to is the Suzanne head, and so that is coming in with our main group input here. So we'll drop this on this geometry line. Now we can give our named attribute an actual name, and we'll call it mix. Now we need to determine how we're going to decide what that mix value is. And whenever we're looking for a simple distance between a point and some geometry, the easiest node to do that with is the geometry proximity node. The geometry proximity node is a little different than most of your standard nodes that have kind of a pass-through functionality where you're sending a geometry into it, something's happening, and then you're continuing that geometry on out. Instead, what we're doing is the geometry that comes in doesn't go back out. Instead, that geometry is inspected, and then something about that geometry is passed along, but not the geometry itself. This is very similar to the way the raycast node works. The geometry input here is really a target geometry, which is our icosphere. So we'll connect our icosphere to that geometry. Now let's connect the distance from the geometry proximity into the value of our store named attribute. And let's talk about what that's doing. Since our store named attribute is looking for a float value, and the distance here, this gray output, is a float value, and it's working on the point domain. So we're looking at setting an attribute for every point in the Suzanne head, because we don't have a selection making it a smaller amount, which we could do if we wanted, but we're not for this particular tutorial. Now for each of those points, we are going to find the geometry proximity to the faces of the icosphere. So we can look at this kind of going backwards, where we have our points and we're getting the distance to the closest face of the geometry. We can change this to find the location of the nearest point in that geometry or the nearest edge in that geometry. There might be special cases where this becomes important to you. For this particular exercise, it really doesn't make that much of a difference, so we're just going to leave it on faces. This will find the location of the nearest face to each point on the Suzanne head in the icosphere. This means if we were to look at those values across the entire Suzanne head, they should pretty much be different for every point, because not every point on the Suzanne head is an equal distance to the closest point on the icosphere. But how can we check that? Well, we can use the spreadsheet screen to do that. If we split one of our screens here and change the type to spreadsheet, we'll see that it has a mix column for the Suzanne head, and it does have a variety of values in it. Let's see what we get when we move the icosphere. But when I click on the icosphere, something's going to happen. Our node tree has gone away, and the mix column has gone away. That's because we're now inspecting the icosphere, not the Suzanne head anymore. To maintain the inspection of the Suzanne head, we need to click the pin icon here in the spreadsheet. Now, if I change my selection, the spreadsheet is going to maintain the inspection of the object it's currently on. What we can expect is if I move the icosphere now closer to the Suzanne head, the mix values should go down. And that's what they're doing. If we move the icosphere further away from the Suzanne head, we see that these continue to go upwards, and really they don't have a bounded top because we can pretty much move this icosphere as far away as we want. Now our mix value is going to be somewhere between 0 and 1. We need to find a way to squeeze the values here between 0 and 1 for our mix. So right now, the distance here will be between 0 and some upper bounded number. And after we get a certain distance away, we just want it to be completely irrelevant. So no matter how far it gets away, it kind of caps out at 1. One way we can do this is by using a float curve node. The float curve node takes a float value in, and if it's below 0, it just sets it to 0, because here at the lowest value, we have 0 mapping to 0. And this clamps those values so that it can't get any lower. And the same on the upper end. If the value is 1 or greater, then it will top out at 1. But what we'll find also is that if we want this to ramp up faster or slower for the transition, we can now adjust that and get some more art direction on this mix rather than just having it be a linear transition. There are a bunch of ways you could accomplish this same effect. This is just one of them. Now that we have this mix attribute, let's go on over to our shader and use it to change the actual output. To blend between the two BSDFs, which are the green lines in the shader tree, we'll use a mix shader node. Here, if I bring the value down to 0, I'm getting the top value, which is the chrome. And if I go to 1, it is the bottom shader here, which is the BSDF that I imported. Let's not worry about the displacement just yet. When we want to access an attribute from our geometry, it's very simple. We use an input attribute node. There are several different ways you can pull attributes, but since these attributes are on the points of our Suzanne head, we want the attributes from the geometry. Here we'll put the name of the named attribute that we used. And now this factor will be that floating point value. Now if I move the icosphere near the Suzanne head, you can see I'm getting the effect I'm looking for. To make this a little easier, what I'm going to do is add an empty. And then I'm going to parent the icosphere to the empty and say object without inverse. And what this means is it's going to snap that icosphere to the location of the empty. Now, if I move the empty, the icosphere moves with it. And I really don't want to render the icosphere. I'm just using it as a sensor, really. My outliner is under my picture here, so I've opened another outliner just below it. And here I'm going to shut off the rendering and the viewing of the icosphere. Now, if I move the empty, I get the same effect. I just don't have the icosphere getting in the way. Now, you may also want to have the displacement also mix between the two materials. And since the displacement is a vector, which is the purple color here, we can use a mix node and change the type to vector. This displacement is coming from the PBR texture, so the PBR is going into the bottom slot of the mix shader, so it's also going to go into the bottom slot of the mix node. Now we should also give the top a vector to work with, and for that I will use a texture coordinate node. I'll duplicate this displacement node and connect it to the normal, and then connect that displacement to the A socket. Now I simply need to use the same factor that I used to mix the two shaders to mix the vectors. Make sure on your displacement node to change the mid-level to 0, because this chrome object doesn't really have any displacement going on, so we'll want that to be at 0. Here I've moved the icosphere quite a ways away, and so you can see the texture here is quite bumpy, and it's got kind of an irregular shape along the edge here. And now, as I bring the icosphere closer, you can see that smooths out quite a bit. Now, this is where the float curve comes in nicely, because if we push the float curve up, then that means the value gets to 0 more slowly. And so you have much less effect until the value is very, very close to 0. Or if you pull it downwards, now it drops off to 0 a whole lot faster. And so it doesn't have to get quite as close to have the full effect. So that's mixing two materials using geometry nodes in Blender 4.5.1. If you are waiting for an update to that old video, I hope this shows you how to do that now. As always, the source files to this project will be available to my Patreon subscribers and to my channel members. If you enjoyed the video and got something out of it, make sure to drop a like and subscribe to the channel. Anyhow, I hope this video inspires you to make something awesome, and until next time, I'll catch you later.